Hello, everybody. Hey. Hey. I got a microphone, wireless microphone. I never had one. Yeah, I feel like a Backstreet Boys, but not the cool one, the one with the goatee and the leather trench. Today I'll be talking about Phoenix. Phoenix is a web framework built on top of Elixir. A little bit about me, and I didn't prepare really this, but I work for Salesloft. I'm a full stack web developer, and hi-ho to all my colleagues. And we are sales engagement platform. We create sales engagement platform, but I don't really want to talk about like what we make, but I would like to say like I've spent a few words how we make things. We have I love my company. We have very strong values, but one of those values that is not really explicit is about being authentic and about being vulnerable, and which creates a great environment. And I would like to perpetrate this kind of value and being vulnerable, authentic with you all today, saying that's my first time speaking at a real conference, and I'm petrified right now, especially, thank you, especially because the previous conference, they were talking about quantum computing, and say, what the hell am I doing here? I got lost when she pulled out the metaphor with the horse and the eagle. So I think the best way to start talking about Phoenix is talking about how the web looks like today. It changed a lot compared to 20, 30 years ago. There wasn't any web compared to 20 years ago. And, well, I should make sure to not let, oh, there you go. Okay. Oh, that's gonna be fun with my accent. That's how people image the web, you know, like millions of users, every part in the world, try to connect with each other, eating server, this very cool stock, Google stock pictures. Reality, internet more like this. You know, you have like all these clients fighting for a few resources and try to grab as soon as possible whatever they want. So let's try to break down this web, how it looks like nowadays. The web is concurrent. It's basically concurrent. And everybody would like the web to be like this. Hey, I got a request. Let me send a response. Oh, another request. Let me send another response. The web is more like this. You have like different clients try to hit a server at the same time. Not only at the same time, also users expect to receive a response as soon as possible. Who want to wait for like high latency for a high latency server? I can already see, like, I can tell you our experience in Salesloft. If our latency go over 80 milliseconds, my boss goes nuts. Not joking. Yeah, joking. Not really, but I'm joking. And this scenario, it's like this is a common scenario. Like I send a request, I'm performing a long operation. But at the same time, I have another user that just want to perform a quick database query. Why do they have to wait? Like, they should not have to wait for each other. And for solving this problem, you need to create like very complex system, like with workers, and create some concurrency. And it became complex and expensive pretty quickly. On top of this, computers are not getting faster, bigger. They are not making bigger processors so I can perform this operation one after another very quickly. No. Computers start stacking up CPUs and cores. So this means that you can perform more operations at the same time. It's a different kind of velocity. Speed, again. I wasn't ready for not using my laptop. And the web is asynchronous. So far, and especially specifically in the last years, at the beginning, web was based on the classic HTTP protocol. Send a request, wait for a response, and so on. Nowadays, business and customer are getting used to asynchronous request. Push event, notification, your DOM that changes based on the state in your server. And this is becoming common and is becoming also demanded by customers. And also difficult to realize and expensive. Also, web right now, I guess most of you right here use the web as a business. Like, or you're an employee or you're an employer, the web for us represents business. And soon we will have like way more device and new ways to connect to the web. Even your toaster could be connected to the web. And this means more businesses. More business means more competition. And you need to be reliable. What does it mean reliable? It means like even if you create a perfect system and you're fast, but you fail, because it can happen that it fails. It's normal failing. But then it makes your whole system fail. It doesn't matter how fast you are, because you're not accessible anymore. And that's the web, how I feel looks like right now. So what is Phoenix? Phoenix is a web framework. I believe that most of you knows what a web framework is. It's a set of tools, standards, and protocols that allow a certain system, allow users to interface with the web. Clients interface with servers. Some framework can be more opinionated, like Rails, some a little less, like Express, they don't provide nothing. I would say Phoenix is somehow opinionated, more on the Rails side. Oh, yes, I forgot the slide. And like any other framework, Phoenix is based on Elixir, like Django is based on Python, Rails is based on Ruby, and so on. But we can really talk about Phoenix without talking about Elixir, which is the programming language that it's based on. And we can really talk about Elixir without talking about Erlang. So let's go and dig a little bit into Erlang. Erlang is a programming language, functional programming language, not so functional like a meta language like would be OCaml, but enough functional. Has like immutable data structures. It's based on concurrency, and we will see in a second how. Erlang was created by John Armstrong in around 1988, and John Armstrong passed away a few weeks ago. And in Europe, they're doing like a huge commemoration because it kind of shaped the programming scene in Europe during like in the past 30 years. And it was created by John Armstrong while he was working at Ericsson for creating GSM networks. So this language was born for creating system where different devices were able to connect to each other, keep this connection, and interact, and being able to resolve and overcome potential failure that you will have in the system. You can imagine like without having the web, oh, sorry. Here we go. GSM connection weren't really solid, so they need to find a system to recover quickly in case of failure. And fun fact, when Joe Armstrong and his team was working on Erlang in Ericsson, they decided to create the beginning starting with an open source language. And Ericsson decided, hey, we can really base our system on open source language. So they left. 3 months after, Ericsson rehired the whole team and they finished to build the whole infrastructure in Erlang. Something about the Erlang philosophy. So everything in Erlang happened into a process. And processes are very lightweight, isolated. They don't share resources. They do one thing, then they die. It's very easy to create and delete processes. And yes. For give you an idea, this is an OS thread where, a state, it knows what's going on. It's able to like interact. This is an Erlang process. It doesn't do much, but in its simplicity, it's very powerful. Poor Ralph. And Erlang is also shipped with a very cool set of tools called OTP, Open Communication Protocol, which comes with a Beam virtual machine, which is the virtual machine where compile Erlang code runs. Nesia, which is a distributed database. Very complex to use, but very powerful. Process management packages. Probably someone of you, if you already know Elixir, heard about Gen Server, Gen Stage. That's what I meant with. An observer, so you can monitor the processes. And it's pretty cool. Like you have like graphical interface to see which processor you're spawning at the moment. Yes, ETS table, which are Redis inbuilt, pretty much Redis inbuilt into Erlang. And a dialyzer, which analyzes your code in building time. It doesn't throw building error, but you will have warning if you like build like somehow like a type checking. Elixir. Elixir is nothing else than macros built on top of Erlang. It's not a new language, it's just Erlang. It's just Erlang prettier. If you try to write Erlang, you will find immediately writing 10, 15 different parentheses on the same line. It's kind of terrible. So thank you, Elixir. The syntax is beautiful. It's English-like. It looks like very in English. It took a lot from Ruby. And it comes with Mix, which is an NPM packet, like NPM, and two different frameworks, which is NERDS for embedded code, used for IoT, and Phoenix, that you're here listening about today. So we talk about how the modern web looks like and how Phoenix is built. Some of you may already have like a hint of where I'm going, but so we say the web is concurrent. Well, remember, Ralph, the process, a lot of processes, very simple. You can create processes. Processes can talk to each other as long as you have a PID, which has process identifier. You can talk to a process. You can even give a name to a process. So it became way easier talking to them. Erlang does great with concurrency because every time you have a request, you create a brand new process. And this process is handled independently and it doesn't have state. And if you need something else from another process, just shoot a message to this other process, which is called actor system. And more processes are not enough, no problem. It's with Erlang and the Beam virtual machine, it's very easy creating distributed system. And even Erlang nodes can talk to each other. So imagine this like server, they can talk easily to each other, and processes inside a server, they can talk to each other. And even different processes on different servers can talk to each other. Just like really, your imagination is your limit. And also we say that the web demands low response time. They want it now, they want it, and they want it now. And computers are not getting faster. Computers, they're scaling their CPU. That's why Erlang shines on this. Because Erlang has a very complex system, yes, thank you, very complex system to distribute resources between their processes. So you will never have a process that will take more resources compared to another. It means that you will provide a sort of, I would say, perceived real time in all the processes. We also say that the web is asynchronous. Push events, chat, sockets. And Erlang does great on this as well. Why? Having a socket connection open is expensive. It's expensive in terms of resource. Not for Erlang. All Erlang processes, if not used, if no message are sent, are idle. And an Erlang process is very light. It's only 14 kilobytes. The time the process receives a message, okay, thank you. Then the CPU resources are allocated for these specific processes. And I will invite you to read this article. Do you know Discord? Okay, Discord is built on top of Phoenix. And Discord were able to achieve 5 million concurrent socket connection at the same time, which is pretty amazing. They achieved this with the Phoenix and distributed Beam virtual machines. Also, we say we're using web for doing business, and downtime is not good for business. again, like in sales all the time, we are like discussing about, oh my God, like this year we did 99.8%. That's terrible. We should shoot for 99.9% uptime. Those the kind of challenges that companies meeting right now. And again, Beam Erlang is very fault tolerant. While you will have like a single process, a single request that will shut down your whole system, because processes are isolated, because processes do not share resources, if you have a single process failing, the single process will die and it will not influence your whole environment, which is great. Even if your server fails, it could happen. Something bad will happen. Remember, distributed virtual machine. You can redirect your traffic immediately in real time to another server. And there are servers right now that like really running for like 25 years. They never got shut down. They never failed, which is pretty amazing. I would like to dig a little bit into timely. I would like to dig a little bit into the system because it's pretty important. It's one of the concepts of Erlang and which Phoenix is based on, which is the supervisor tree. So you can have a single process that will do something very simple, like as an API where you can send a message, perform some operation, and then it dies. Then you can have a supervisor process. What it does, it takes a list of processes, a list of workers that have a very specific job, and it will start those processes. There is something else called dynamic supervisor that can start and stop processes based on some specific request. But the idea is you have a process that will control other processes and will restart them or kill them based on some rules. So you can decide, hey, if this process dies, just kill the whole tree. And each supervisor can start other supervisors. So imagine such complex tree that you can create. You can create like very complex application tree and decide like, if this part of my application dies, just kill at this point. Don't let the whole system be influenced. So you have like very isolated, you can isolate the part of your application as you prefer. And there is something that like often I hear is, okay, this is very cool, but this is also very, probably is gonna be very complicated. You talk about processes and send message between processes and, you know, virtual machine and gen state, gen server. The only thing that I want to do is just create like a web server, you know, like I don't have a complex business. I just want to create a website, internet shop, nothing more. Phoenix is just a framework based on MCV, model, view, controller, nothing special. You can use Phoenix as you can use Phoenix as a normal web framework, Rails, like Rails will be, or Spring, or you can dig down and take the full power of Erlang. But let's see how simple it is, how the parts that made Phoenix. We have the controller. I couldn't find better icon, I'm sorry. Which the controller is made by two, I would say one is not a part, but yeah. So we have Cowboy, Erlang Cowboy, which is a web server. Make a request. The cool thing is our Cowboy, each request that you receive, it creates a new process. You know, you have a new process, you have a PID, you potentially have a name, and you can do whatever you want with this process, with this connection. And here the plug comes into play. Plug is more a specification, and for a set of functions, composable functions that takes a connection, a Cowboy connection, you can apply some modification to those connections and return the connection itself. So you can create, pipeline to operate on your connection, and you can use them for create authentication, for changing your headers, sending data to Datadog, etc. Then you have Ecto. that represents your model. Ecto is a layer on top of your database, which is made of the repo, which represent a connection to your database. Again, a connection is going to be a process that connects to your database. A schema that represents the data structure. Those query does inject the data into your, okay, you guess your use now. And the change set, which is, in my opinion, the coolest part, is like a list of validation and modification that your data has to go through before being used by your application or before being saved into the database. They're sort of like the gates, the quality gates of your data. What makes Ecto very cool is the fact that it's a whole layer on top of your database. And you can create module on top of this layer, which makes Phoenix database agnostic. You have an existing project, Rails project, with a Postgres database already in it. Say, okay, I can't do Rails anymore. You can go ahead and plug, with low effort, you can plug a Phoenix application on top of your existing database. Define your schema, basing on your table, there you go. You're ready to go. And the view. The view, everybody, I guess everybody knows ERB, handlebars. Remember, you have like your browser, make a request to your server, your requester grab an HTML, throw some JavaScript or Ruby or Elixir Magic, and you render the HTML. Phoenix took a step further, and we have this new feature. Well, it's not in production yet, it's in alpha. It's called Live View. And what it does is pretty cool. The process is still the same. You send a request for a view. The server grabs your HTML, throw in some code, but also it creates a stateful connection between the view and the server. So you literally have a live website using WebSocket-like on a server-side render page, which is pretty amazing. No JavaScript. You don't have to write any JavaScript, ever. Ever. If you want, you cannot. So, again, this is cool. I can create live application. Let me show you one application. Just give me 1 second. So trees is the name that I gave to, let me see if I can get out of here. Now, yes. So this is a very simple application. You have, it's a tic-tac-toe, and let me open. This is like a live tic-tac-toe with a matchmaking, with a matchmaker. What it does is like you create like a tic-tac-toe, you join a game. If you're another person, join the same server, you get matched to the first game available. Otherwise, he will create another game. There is no user. It's like very simple, but very powerful. Like you can create like, I create like a live game without writing a single line of JavaScript. Now you will ask yourself, hey Marco, you have 3 months to prepare for this speech. Why you couldn't create like a better application? This looks like it's sucking. Well, there is a reason. I start beginning like, my first thought was, let me create a super cool application. Phoenix, I'm gonna start it, gonna make it great. I'm gonna create user authentication, etc. Then I was thinking, okay, people all the time who do not use Phoenix give me shit about, hey, I need to build something. I need to build it now. I'm going to use Rails. I can spend time without Phoenix. I need to know, like, it's complicated and it's hard to set up. Well, the reason why I stop here is the following. Oh, no. Do I need to start over? Give me 1 second. I'm sorry, guys. I'm very bad at this. The reason why I left it like this, because everything I built, the application that you saw, it was built in less than 1 hour, 57 minutes, and only 250 lines of code between the server side, the matchmaking, and the view. And if I can show you the view, for creating that view, there were like less than 10 lines of code, which makes Phoenix one of the most productive framework on the market right now. For concluding, like you can have like a web framework based on a very common technology, MCV, with a beautiful Elixir syntax, because I promise, writing Elixir is beautiful. It just gives you like a peace of mind. You are able to access Erlang because you can write Erlang inline with no runtime cost. You can just use a column and start writing Erlang, invoke like an Erlang module. You can handle like millions of connections at the same time. It's stable. And really, it's one of the most productive, reliable, and fault-tolerant framework right now on the market. And I don't see a reason why not using it for how the internet looks like right now. Also about the community, the Elixir community is great. Worldwide, there is it's present with the Erlang Ecosystem Foundation, which is a foundation that collects a lot of companies around the world, and their mission is to evangelize Erlang and Elixir in the world. And if you have a company and you would like to use Elixir, I will invite you to visit the website, and you can contributing through like through pushing open source code, contributing to the open source project, or if you can, even economically. And luckily, we have our great Atlanta Elixir meetup, and I will invite you to come June 12 at Salesloft. And I also brought stickers. So by now, you probably figure out that I have an accent. And I'm Italian. And this is a shameless plug to my country. Italy, yeah. Even people could not believe it, but Rome, Italy, and specifically Rome, has a great Erlang tradition due to the presence of telecommunication company. There is Telecom Italia, which is one of the biggest telecommunication company in Europe. And we have a great Elixir and Erlang community. So if you ever go to Italy, and if you want to meet some developer, just let me know. I can connect you. I visited them like a few months ago. They're great people. And that's it. Yeah, if you have any question. Yes?
What would be the difference between using Erlang or Elixir, Phoenix, and Insulet stuff on the back end versus using something like Golang? Because I know Golang handles concurrency very well too, and I know a lot of people be using that. So I don't know anything about Phoenix. I just kind of want to know.
Yeah, so for answering this question, we should go down like to the benchmark, like figuring out the numbers on the benchmarking. And we probably could stay here like a few hours. But what makes difference is like the Beam virtual machine handles those processes. I know that Golang and Elixir and Erlang use the similar actor system for like handling processes, but the secret is all the work that has been done in the virtual machine. And I can share some resources with you. I'm probably not the best person to talk about that because we are going down in very like detailed like mathematical theories.
Yeah, maybe we can do it outside of this.
Oh, yeah.
Pretty deep into Golang, that's why I asked.
Oh, okay. And like, again, I'm here. So my mission for today was to try to evangelize Phoenix as a very productive business framework. And yes, like it's being a functional programming language has a whole another level of abstraction based on different like mathematical theories, which I may not be the best person to talk about it, but I can introduce you like for other Elixir Erlang expert that are like way more knowledgeable than me, and I'm pretty sure they could provide all the answer that you're looking for.
What's the learning curve like for a total beginner?
For a total beginner,
Sales Loft. I guess not everybody that works there comes with Phoenix knowledge.
no, but pretty much everybody pick it up kind of quickly. Also because like our main stack is Ruby and Rails, and the passage between the shift from Rails to Phoenix is pretty fast. I would say the moment that you kind of pick up the concept of pattern matching and immutability, you're pretty much done.
So kind of to bounce off of his question, outside of just like the docs for Elixir and Phoenix, are there any resources that you recommend for getting started with it?
Oh. No. Like, I don't know, like the X docs, which is like the docs that like create like the documentation Elixir ecosystem, they are pretty great. There is Elixir School as well. It's great, but I usually found everything I need like through the documentation. They're pretty good. And books, yes. Elixir books are great. If you like the editor Pragmatic Programmer, they come out with amazing Elixir like reading. So I would strongly suggest to purchase one of those books. Well, thank you so much.